Hello, everybody. Thank you for joining me. And I'm going to talk about cloud cost in general and how to run your workloads, and especially serverless workloads, for free. And who wouldn't want that? This is actually a part of my full session I'll be giving in October in Berlin in the serverless conference. But you get to get a test now. So we'll talk about cloud and serverless cost and tell you how you can run everything free of charge and even show you a few examples to prove that it can be done. But first of all, who am I? My name is Dan Erez. I've been around for quite some time. Seen a lot, and lately I've been doing cloud architecture and working on AI tools and how to combine them in software development and in DevOps, and also write in usually in Medium. So I'd be happy if you check out my articles there and give me some feedback. I love feedback. But let's start. And my story starts a couple of years ago when I worked for AT&T. And I'm not sure if you're familiar with this company. It's a large, very large actually, telecommunication company from the US. And I've worked in their Israeli branch. And they have, I think, almost 300,000 employees now. And that's important to the story. You'll understand why a bit later. And a couple of years ago, they've decided to eliminate most of their data centers and move to the cloud. They had nothing in the cloud uh, up until then. And they decided to move everything. And their expectation was to save 70% of operational cost by moving to the cloud. I can give you a spoiler, they didn't. Actually, in some cases, it was even more expensive to run stuff in the cloud for various reasons. I guess you probably know most of them. Just as a side note or an anecdote, in the total, they actually made a lot of money by moving to the cloud, but not by saving operational costs. Thing is that when they built those data centers back, I don't know, in the 70s or 80s, like 50 years ago, they bought cheap land in the outskirts, right outside the major cities where land was extremely cheap. Basically, they got it almost for free, and they've built those huge warehouses and data centers and everything. And it remained like that. But after 50 years, it was no longer outside of the cities. It became like hot areas, real estate places in the city next to the set of the cities which grew a lot in those 50 years. And now the land is worth billions. So they actually made money, but that's beside the point. And part of my job there was to evaluate if it makes sense to move stuff to the cloud. And we recommend to keep some applications on-prem because of the cost. And now when this project is almost finished and many applications are in the cloud, they realize that the cost is very high and they probably won't return, but I guess the financial expectation were false. And I hope you remember Dropbox, the cloud storage company, which started working on Amazon, hosted all of the files there, and I think it was 2015 when they did what's called repatriation and move moved back on-prem again due to high cost. Right, so I think it happens in many cases. I've heard of a few cases lately as well, and I think that the consensus currently is if you're small or just starting in the cloud is very fast. You don't have to buy and purchase any hardware or any DevOps. You can do everything on your own very fast. And usually clouds have a very generous free tier that you can use, and you only start paying once you have customers, and sometimes quite a few customers. But once you get really big, like millions of users, etc., you start to pay a lot of money to the cloud providers. But at that point, you're already locked in this cloud provider, and it's very hard for you to go back. It's a major effort that will cost you millions, and many companies do not start this kind of challenging project, so they just stay there and pay the cloud provider a lot of money. So it's like that on purpose, of course. So pay attention on what you're getting in and try not to be locked in as much as possible, not always 100% possible. And this is the result, right? Thank you guys for making Amazon or Google or Microsoft very rich. These are like to 20 or to 30 billion dollars earnings in a quarter, and it's always going up. I think that even a few uh, days earlier, I've heard that Microsoft had like record profits from their cloud services, and uh, again, thank you guys for enabling that. So when companies are struggling with high costs of compute and other stuff, serverless always come to mind, right? Because I guess you probably know most of the advantages, but the left one here, the pay for what you use, I think it's the most appealing one, right? If we don't have a lot of traffic and I'm just starting, why should I pay for anything? Right, and that's the major effort, and I think it it, it sounds like the most fair deal, right? You don't use, you don't pay, and you only pay for what you use, so it makes sense. And like I said, they have a very generous free tier in Lambda. It's a million invocations per month. In Google, it's the same thing in Azure as well. Sorry. So it's a very appealing proposition, and nowadays it's not just compute, right? Not just functions, but also databases, which are serverless, and basically almost any resource can be charged by usage and does not require you to install or own anything. And many other companies, not just the big three cloud providers, are offering um, for example, edge functions, right? Cloudflare and even Supabase that does a kind of a serverless database. They offer their own edge functions. So it's easy. It's catching, and I've recently built a few projects without writing one line of code and paying anything. I've used Lovable as the AI web application generator, and they also have a free tier I used, and they have like an integral connection with Supabase, which also have a free tier. They let you have up to two databases, two projects, and in there you can build quite a few tables. So I did it using Lovable without writing any code, and I have a few running applications that people can actually use. So serverless is amazing. Again, up to a certain point of usage and complexity of a system, of course. But starting is easy. Just to be fair, sadly, serverless is not the solution for everything. There are issues like cold start, right? Although you can deal with that with keeping like one instance always warm, but paying for it, of course. And there is the vendor lock-in because APIs are different between different providers. So that's a point that you should note as well. Things work in a certain way in certain providers. And of course, if you don't run stuff locally, it might be harder or more expensive to debug stuff, right? How can you debug a Lambda function as you do when stuff is running on your own machine, right? Or at least locally. So there are a few issues, but I think that the stuff that bothered us the most is that it's not always the cheapest solution, right? It's the cheapest and the easiest when they're simple. So, uh, some typical usage patterns, like if you have a peak at the end of the month or peaks here and there, but if you have sorry, a constant number of requests that are happening all the time, and then the number of requests might be high, and you're going to start paying a lot of money for it. So take that into consideration. Although if you add the lack of DevOps or hardware into the equation, it might still be cheaper, but not always. So pay attention. Serverless functions can be costly, right? But we are not here to talk just about cost. I'm here to tell you how you can eliminate cost and run your serverless workloads free. So, yeah, well, what would you say if I tell you that you already have a free cloud and the core of this idea is to use employees' machines, right? So bear with me and think about the fact that all employees have machines, right? Laptops, desktops, and large companies like AT&T have a lot of employees and a lot of machines, and those machines are idle most of the time, right? Outside working hours for sure. And that's most of the time, right? Outside working hours and on weekends. But even in working hours, you don't really usually utilize your machine to the max, right? I'm sharing this presentation now, and my, I don't know, maybe even 4 years old laptop is not even breaking a sweat. So you can run a lot of stuff on each machine, and is using that. So basically, we are wasting many resources. And think about data centers. Everybody would be outrageous and upset if you utilize 10% of these data centers, right? But they never think about it when it relates to users or, sorry, employees' machines. So we can use that. And I think that serverless workloads are a perfect match for that because they usually don't run for a lot of times and they are suitable for varying environments, right? And maybe even different types of hardware. And if you uh, think about maybe Docker containers, they're all adjusted to being very volatile and maybe get killed on one machine and reappear on a different machine. Things are code is written for that nowadays, so it's a perfect match. And maybe you think now it's a great and innovative idea, but I have to be modest and say that there have been other projects for utilizing people's machine when they are idle. And if you're as older as me, you might remember SETI. It was a NASA project in the 90s, I think. It's SETI stands for Search for Extraterrestrial Intelligence, basically looking for aliens. And back then, we all wanted to help, and we were naive enough to download an exe from NASA. It was the pre-viruses era. And we ran it, and whenever our machines were idle, right? I think they used the on idle event. They started doing some calculations and see if there are really aliens out there. We never got the results, by the way, so uh, they might found something and never told us. And this project ran for 20 years or so, and was just I think closed a few years ago. So they probably did a lot of calculations. Not sure how many users they got at the end because people are no longer running access on executables on their own machines, but they might. Anyway, they use the same idea with a slower internet and much simpler option to do stuff in parallel and utilize resources correctly. But I think they were the first or the first global effort. So this is the idea, and just noting if you're dreaming about um, training AI models and using this like global compute power to do so, it's possible, right? You don't have to buy the hardcore $1 million GPUs. You can use this one. I think it costs $200 or so, and it's quite strong, right? It has 8 gigabytes and a lot of um, processing units that are usable in training, and it's possible to give them to any employee in the company and get amazing results. So think about that too. So now that you know the what, we can think about the how, right? And my first thought was to use Kubernetes or containers because they're common now that you can find them almost everywhere. Kubernetes gives you an orchestration layer that enables you to start and set up and monitor clusters easily. Um, they run isolated from the host machine, which is something that we desire, right? No employee would love the fact that we run uh, alien workloads on his machine, and he might be interrupted by that. Uh, I don't know, file erase or so. So the isolation works, and we can run it anywhere, of course, like every operating system, etc. And they even have now it's not so new the JobSet API, which is designed exactly for that. You can like submit jobs for to the cluster, and it will find the right place to run this stuff for you. So there are like a few points uh, for uh, executing this idea in Kubernetes, but there are some drawbacks as well. First of all, you still have to install stuff on an employee machine, right? You have to install Docker or an equivalent container management. Maybe download some images. It might become heavy, and you have to manage it, right? And we all know that despite all of the tools that you have out there, managing a Kubernetes cluster and maybe even a hybrid one is not an easy task, might be confusing with all the various configuration options that we have. And even heard about uh, Docker being jailbroken, meaning getting access to the host machine, which, like I said, we don't like. So I started thinking about other options and came with this amazing concept that I think even better. Browsers, right? Pretty surprising because you usually think about the browser as a client and not as a server, but let's think about it, right? First of all, everybody has a browser, right? Even on mobile phone, for example, which don't have Docker, you still have a browser. Even if in the most simple machines, you still have a browser. It if you install an operating system, you probably get a browser. The secretary has a browser. The guy downstairs that look after whatever has a browser. The CEO has a browser. Everybody has them. It's free, of course. You don't have to install them or pay for them, and it's very secure, right? If you, I don't know, maybe even 20, 25 years, maybe even more. Um, of browser development made them very robust and secure. And large companies like Google is maintaining that for you. So basically, they're working for you and installed everything for you. That's very nice of them. And you can run a lot of stuff on that, right? And obviously, when you think about browser, you think about executing JavaScript. But nowadays, it's not just JavaScript. We have WebAssembly, and you can compile a lot of languages into WebAssembly. It can be Go or Rust or C Sharp, even Java. So you can basically write in almost any uh, common uh, programming language and compile it into WebAssembly and run it in the browser. So it does not limit you to anything. And it also has a lot of APIs that you can use to build application, not just a container like Docker. It has APIs for data storage and even an actual database inside. You can manage session, multi-threading, web workers, even APIs for running GPUs, right? So we have a ton of APIs that you can easily use inside the browser, and it's faster, right? So someone did this experiment, and if you take the start time of a container into the equation, then running stuff in the browser can be 10 times faster. So a lot of advantages. And if you take it the how one step further and think about the architecture, you can do it in many ways. But maybe one of the simple one is having some kind of server, and this time maybe a real server. Doesn't have to be, but um, maybe it should be that accepts jobs, right? Workloads that you want to run on, well, everywhere. And whenever this any client is connected to the network and is idle, it can ask for a job, or the server can manage that, doesn't matter, and execute the job, send the result somewhere, and ready for the next one. This way we can handle a lot of parallel work jobs. We can make it more and more complicated as we want. We can, for example, do uh, uh, work in two modes, right? A synchronous mode where stuff is pushed through a web stream and we get the result back. Or we can work with a queue to have some kind of asynchronous event-based uh, job running mechanism. And again, we can take it further on according to the needs and the requirements, from simple to very complicated. And we can play with this idea to achieve whatever we want. For example, we can run headless browsers, right? Instead of the user to see the browser or the tab that we open to run jobs, we can do it headless without him seeing anything, the same way we do with automation tests, and get slightly better throughput on that machine. And we can use other APIs in the browser, for example, web workers to utilize multiple CPUs and to do stuff in the background without interfering with the user interface. So we can play with that, and things are always advancing. More APIs in the browser, more stuff we can do. And we can even take it to the next step and think about machines at home, right? So you can be part of a global network, sharing your resources, maybe even selling your resources, right? And for in return, you can get uh, other CPU time, CPU time for other machines out there, like maintain some balance, like a bank balance between you and the rest of the world, or you can get actual benefits, money, discounts, whatever. And this way, companies can have access to a massive amount of servers and achieve stuff that they cannot do uh, on-prem, or will cost them a lot of money if they pay some cloud provider. And I think it relates to the Web3 uh, 3.0, which nobody can actually define what it is. Or we know that it talks about some distributed global network, democratize the web, etc. And I think that maybe this idea could be it, right? If we all be part of the network and share resources easily with our browser without installing anything in a very safe environment, then we might actually build this global network. We have to think about security, of course. And there's a difference between on-prem and uh, global execution. And if we want to be safe, we just run it on-prem. We can even group our machines into group. For example, maybe the financial department with all my computers will only run financial related workloads or not, right? So some workloads can be run across the company. Some are more discrete. And we can think on several measures of how to protect it in the public domain, although you can never fully protect it. So if it's like a very sensitive information, run it on-prem, not even in the public cloud, right? Don't trust Amazon or Google. Run it in the house. But for everything else, you can use uh, this approach. So we'll develop that a bit more in the full session. But for now, since we don't have much time, I'll show you just two examples. I have quite a few, but I'll show you two examples. I've set up this server and the web page that's connected to it by um, WebSocket. Let's restart it, and right, I'm connected to this server, and I can submit jobs to the server, and I'll submit two kind of jobs. One of them is image classification, right? I've used the TensorFlow.js library and the MobileNet stuff in it. And I can easily see a few lines of code and you can classify an image, which is great. And it's actually very useful, right? In social network, etc. In forums, people are constantly uploading images and you have some responsibility to check that it is uh, not an inappropriate image, and employing humans for that is too expensive. So why not use a model to do so? But why pay a cloud provider if you can use the employees' machines to do it? Right, that's one example. And the other one is to generate a PDF. That also a very common use case. If you generate paychecks or messages or whatever, you can pay for that compute power or simply run it for free. And as you can see, this is a simple code that generates some fake invoice based on some argument. So let's see it in action. I'll submit a few jobs. Let's start with the invoice, right? Let's erase that and take another sum. And I've submitted and got a response. Let's see it here. Yeah, I got the job to my browser, and my browser actually generated the invoice with the sum I've given it. Nice, and it was actually very fast, surprisingly. And if I want to classify stuff, I have two images here. Image one, which is a cat, and image two, which is a dog. And let's try that. Let's start with last time I checked was image one, so let's change that. And I've sent the response. I got a response, so we can see it here as well. Yes, and image one is a cat. Let's change that to two. It's quicker this time. Sorry, actually, I see it. Did I get an answer yet? Oh, I got the answer here. Oh, it took a little bit, so I guess now we can get an answer. Yes. And Image two is a dog. Great. So let's summarize a little bit. The idea is using the employee's machine for free. You can do it in several ways, but I found browsers suitable to run serverless workloads in an easy way. And we're already working with browser and writing JavaScript, etc. So it's easy to build it. And I found that having a central server and then pushing jobs to client browser, whichever which one is available, proved to be fairly easy. And you can do various stuff with that. And again, in the full session, I'll elaborate on many parts of this presentation and show some more examples in the demo. So you're invited.